Welcome to the Allison Loves Math podcast. I'm very excited to introduce today's guest, Catherine Roberts. She is an applied mathematician, the executive director of the American Mathematical Society, and a professor of mathematics at the College of the Holy Cross. And today we're talking about a fun topic. It is about the importance of communication skills, and the many different ways it comes into play in math and in math education. And so I'm really excited to talk with you about this today. Catherine, welcome to the podcast.
Well, thank you so much, Allison. I really appreciate the invitation to speak with you today.
So I don't know, maybe let's start off with talking a little bit about your background, because you have a liberal arts background also.
That's
so can you share a little bit about that?
Sure. So as an undergraduate, I went to a small liberal arts college in Maine called Bowdoin College. And while there, in addition to getting certified to be a high school teacher, I majored in both math and art history, and took a broad range of classes as an undergraduate. And it's astonishing it's nice to start there, because over the course of my life, so many times I reflect back on that grounding that I received for that liberal arts education, and how much it's helped contribute to to my career and to the work that I've done. And then from there, I went to graduate school at Northwestern University, which is just north of Chicago in Evanston, Illinois, and earned my PhD in applied mathematics and engineering sciences. So I did research in an area called integral equations. So using tools from analysis to understand the behavior of a particular set of integral equations. And then became a professor and had to move around a couple of times to satisfy my two-body problem. I was married to an academic chemist, and had this wonderful opportunity in a position that I had in Arizona to get involved in a research project that had nothing to do with integral equations, but it was a mathematical modeling project that had to do with modeling whitewater rafting traffic through the Grand Canyon National Park. And so that was a real pivot for me in my career. I continued to do research on my more theoretical math on the integral equations, but also started learning about environmental resource management and mathematical modeling.
Very cool. So let's start a little bit at the beginning. All right. Okay. So I know you value your liberal arts education a lot. What are a few of the specifics that you feel like you got out of it that have benefited you the most?
Okay, that's a great question. Thank you. I remember in high school thinking that all of the subjects and the classes I took were completely separate and unrelated. That math had nothing to do with English class, that had nothing to do with my history class, etc., science class, whatever. And in college, while I was taking following this liberal arts curriculum, I started to notice the interconnections between these various fields. And I found that really exciting and really interesting. It especially happened in my art history classes, because those classes are looking at art, but you're looking at in the history of art, but you're thinking about what led to these new developments in artistic expression. So you could see the influence of poverty on an artist, or the influence of a war on an artist, and you could see how whole movements sort of could be explained by the context in which they were emerging. So I started to think that everything was connected, and that was a real revelation for me as an undergraduate. And I feel that way about mathematics as well. We might think that algebra is different from geometry, that's different from calculus, and then there's other things I've heard of, like number theory or differential equations or something. But in the end, there are these fundamental truths that kind of bind it all together and make it be a coherent story. And I find that those connections really interesting. Another thing that I think of when I think of the liberal arts education is communication. You do a lot of writing in college, you write a lot of papers. I see students in my math classes who will say oh, I love math and I love how I don't have to write. And I'm thinking, what are you talking about? Like you're learning how to write proofs. Like you're learning a very specific kind of writing, and you're learning how to be logical, and you're learning how to make your arguments in ways that hold water. I think communication is a key element of being successful in mathematics, as much as it would be being successful in politics or anything. So being able to write clearly, communicate clearly, think logically, those are the kinds of skills that emerge not just from mathematics study, but can emerge in from lots of different areas.
Right. I guess what I'll say is I couldn't agree more. I majored in English and math in college, and
there you go.
And it's been so fascinating to see how the two subjects are so interconnected and how important one is to the other. Especially with math, I think, well, I guess, okay, I can talk about it from the teaching perspective, right? I teach math at a community college, and, without the ability to explain math concepts or think about different ways to explain it, there's only so much that you can do in terms of teaching. And it's interesting that, I think because I teach the lower levels of math, a lot of remedial math classes and stuff, I actually think my English major has been way more beneficial to my teaching than my math major, actually. And I'd like to hear about your research and how it came into play with that, because I sort of dipped my toe into a little bit of research, as an undergrad and in my master's, and I felt like it was really helpful there as well. So I'd love to hear about how those communication skills and your liberal arts background sort of came into play with your research.
Sure. So I'll focus on the research project that I did with the Grand Canyon, and that was quite some time ago. But essentially, the question that we were exploring was, how to advise the National Park Service on how to best schedule the launches of these whitewater rafting trips that go down the Colorado River, and it's long. It's like over 200 miles down the river, and there are boats that are rowed, so they take many, many days to go those miles, and then there are boats that are motorized that can get the whole length of the river trip in 6 days. So from 6 days to a month, these trips would take. And so they're all interacting with each other as they go down the river at different rates, and they're kind of competing for the best campsites and that sort of thing. And the Grand Canyon National Park wants to preserve the setting so that everybody who takes one of these trips is experiencing a wilderness setting. On the other hand, the wait list to get on the river was really long. So if you had a lot of money and could pay one of the commercial outfitters to take you down, you could go in a year or two. But if you knew how to row a boat and wanted to just kind of wait your turn and get a ticket to be able to go down the river in your own boat with your friends, the waiting list was at least 12 years long, sometimes even longer for people. So there was a lot of conflict in the river on kind of like who had the right to go down and what's the sort of maximum capacity of the river, yet we also want to minimize interactions between different parties, and we want it to preserve that wilderness experience and minimize the impact on the environment. So it's a math problem, right? Think of the river as like the x-axis, and at x = 0 is where all the boats go on the river, and they make their way down the river at different speeds. So there's simple graphing. I mean, you could just sort of graph like each day where each trip camps, and you could see, some go 200 miles in 6 days, and some go 200 miles over many, many days. So the slopes of those lines are different. So kind of understanding the rates and the slopes of those lines is important. And then it got a little more complicated than that as we went on, because we needed to incorporate human behavior. So we needed to do some survey research to try to understand how decisions are made on where to camp, where to hike, what to do. We needed to involve social scientists on that to understand, how decisions are made and to figure out how to code that. We didn't want this to be a deterministic model. We wanted to come up with a computer simulation for human behavior in this recreational setting. So we needed to use some artificial intelligence. We needed to collect a whole bunch of data. So I had students collecting data on the river for over 2 years, and we had to collect that data and load it all up into big databases and analyze it and see what kind of patterns we had. And then at the end of the day, we had this pretty complicated computer simulation model with some higher level math than what I'm describing right now embedded in it. And this required that I not only understand the mathematics, but be able to understand the psychology of people. I needed to learn about the history of whitewater rafting on the Colorado River. I needed to learn a whole political dynamic there between with the private boaters who were waiting their turn for a ticket, the commercial outfitters who are concessioners with the National Park Service, and how that whole interaction sort of works. And what was interesting about this mathematics is that with my integral equation research, I would go talk about it at a math conference and publish my results in a paper. But I knew kind of the 10 people on the planet who would really be interested when I had a new result. But this was different because this research, people really cared about it. They were wondering what was the wait list going to be able to be reduced so that they didn't have to wait for 12 years. Would more people be able to get on the river without diminishing the quality of the experience? Those kinds of questions. So people were interested. And that was totally different for me as a mathematician because I was getting calls from National Public Radio. I was written up in Science News. I remember giving a talk, being sent by the Park Service to give a talk at a library in Denver, and 200 people showed up to listen to me talk. And they didn't want to know all the details about the mathematics, so I had to tell a much bigger story. And that's where the communication came in. I couldn't go in and just get into the technical details of the math, but I needed to explain why you could trust what we were doing and also what the limitations were of what we were doing. Because a lot of people don't understand with a math model that it's just a shadow of reality. You capture the variables that you can, but it's done inadequately and it doesn't take everything into account. So to help people understand the limitations and also the strengths of a mathematical model and to explain that to a general audience was really challenging and a lot of fun. And that was when I said, gosh, I'm so glad that I went and had this liberal arts education and that I can tell a story without making the mistake of getting too technical too quickly, or that I can tell a story that is sensitive to different perspectives on what I'm saying.
Right. Yes. No, I can see how that's such a big change to present something to that large of an audience, and, did you prepare, I guess, how do you prepare for the presentation? How do you prepare for the presentation aspects of your research? I don't know.
Yeah. So, back then I was preparing PowerPoint presentations and I realized I needed to be much more creative than what I was doing when I would talk about my math research at a scientific conference. I included, videos of people whitewater rafting down the Colorado. I included, historical timelines about the Park Service and when the Grand Canyon became a protected area. So I had put in history kind of notes in there. I included, quotes from famous environmentalists and things in it. And that was very different for me to kind of start to think about how to tell a story about mathematics in a way that would be appealing and understandable to a general audience. That was really the challenge there. And I wanted to get some math in too. I wanted to show some graphs and charts and results. And, I'm not going to show all of the complicated equations behind things, but I wanted to be able to show and get people to look and say, like, see, when we see that these lines are steeper, like that means that they're going faster, you know, like the steepness of a line lets you know about the rates that things are changing, you know. So I was inserting language that we use as math teachers all the time into a story about the world that people could understand. So they'd be nodding and not realizing that they were swallowing some mathematics, not necessarily realizing they were nodding about some mathematical concepts.
Right, right. Yes, and that's a job well done if you can do that. Have
Well,
them following all the math without realizing it, you know?
Right. Yeah.
All right. So another way that, you know, communication comes into play in math, well, that I was thinking about, you know, after our last conversation and sort of leading up to this, actually, there were a couple of things. So one is in teaching, right? How do we incorporate that into our teaching? And the other one too, I think, is just almost in terms of a understanding of math as we're learning something that we personally find complicated, right? That step of being able to articulate what you've learned and discuss it, I feel like is a deeper level of understanding, you know, and if the liberal arts or communication skills can help with that, right? Having those discussions or being able to write a paper, sort of find a process for solidifying your understanding of something. Sorry, that's not even a question. That's just
No,
I guess I was wondering if you had any thoughts on that.
Yeah, you know what when you're saying this, it's reminding me of something. So after I'd been a professor for many years, I got involved with this professional development effort tied in with this Vermont Math Initiative, and then called the Intel Math Program, where I was partnered with somebody with expertise in math education, and together we were teaching adult K through 8 school teachers math content.
Okay.
And that was transformational, because here I was as like the math expert and partnered with somebody who was an education expert. And we had so many kind of barriers and assumptions to work through. But what came to mind when you were just telling that story was remembering how we were just talking about something like as simple as positive and negative numbers. And I realized while we were talking about that unit with these elementary school teachers that, like, I didn't understand negative numbers appropriately, you know, and I didn't even understand like subtraction appropriately. Like, is it take away? Is like, I guess I was thinking of subtraction always as taking away. So if you have 5 minus 3, you know, you have 5 objects and you're taking away 3 objects and you have 2 objects left. So I was thinking of subtraction as a takeaway thing. But then, you know, through that experience of working with elementary school teachers, I realized that you can also think of it as a difference, right? If you look at 5 and 3 on a number line, the space between them is 2 spaces. That's the difference between 5 and 3, and difference and subtraction, you know, are all the same thing. And it was really like, I mean, it was really a revelation for me to see how thinking of subtraction as taking away or thinking of subtraction as a difference were 2 different like psychological ways of thinking about subtraction, and that the difference model is exactly what we use in calculus, and it's exactly what we use in higher level mathematics. We don't think of subtraction as takeaway nearly as much as we think of it as a difference between 2 quantities. And yet when we would talk to the elementary school teachers, they, like me, 100%, when they think about subtraction, we're defaulting to subtraction as takeaway, and it's not difference. And it absolutely like rocked my world to recognize that little difference that can happen in elementary school, you know, that if a teacher can grow to think and to teach about subtraction as not only taking away, but as the difference, like the space between these 2 values, that alone would set up students to be able to not think of slope and difference and like all of these issues in calculus that I see, and in algebra that I see students struggling with, like boiled down to a difference in thinking about subtraction. And that was a real revelation. And it really emphasized to me how we need to talk to one another, and we need to think about that. And when we are teaching and a student is having trouble understanding what we're saying, we don't just say it again in a louder voice. We need to come at it from a different angle, and to try to kind of introduce these alternative ways of viewing the same subject. And what I loved about that Intel math program is that they would always say, there are lots of different answers to a math question. And we might decide that one kind of answer, one format of an answer is sort of preferable because it's sleeker or, more compact or whatever, but there's lots of different answers, and that's okay. Like, you need to just kind of come at it with your curiosity and your creativity and things. So I know it's a little off topic, but
oh, I love it.
Hearing you say that reminded me about that whole thing, and then saying, okay, then my job is to help for all the elementary school teachers in America, like in the world, like think about subtraction as a difference, not as a takeaway,
Yes, no, I think conversations like that are so important, because I think that's something that I hadn't thought about either until my kids started school, and now they're in elementary school. And just more recently, I've been having conversations about elementary school math and sort of digging into that. And in all honesty, this will be a little off topic, but the very first time one of my kids asked me a question about math, and honestly, I don't remember what the topic was, but I remember that I was like, oh, you just set a variable for this. And she was like in first grade. And it was because, I was teaching college algebra, and you just set everything up as a variable. And it was just so funny how completely inappropriate it was, And so, one, I find it fascinating, the different language and different communication skills and different way of teaching. You use it different age levels and different abilities and stuff. And then the other thing that you just pointed out, which I think is really interesting, is communicating between different levels of teachers, right? Elementary school versus high school versus college, because that was another thing that I found surprising, was that, I've had a couple of conversations, where I was talking from the community college math professor perspective, who was teaching remedial math with students who, I was trying to figure out how they got through 12 years of math, and then they get to school and they're in pre-algebra, because we have to go back to like those multiplication skills, and then talking with elementary school teachers, and having somebody say, gosh, I never thought about what happens when they move past the class and they didn't actually learn that skill, And I think a lot of that does come from us just sort of segmenting our conversations, only talking about elementary school math with other elementary school math teachers, right? And only talking about higher ed math with higher ed math teachers. And so, I don't know, I love your story about that, about thinking about subtraction from a totally different point of view.
Well, I'll tell you, we can circle this right back beautifully, Allison, to the river again, to the Colorado River, because think of our journey through life and as mathematicians, or as anybody, as humans, we're on a river, that starts and from the perspective of the student, we are passing through first grade, second grade, third grade, perhaps on to college, perhaps beyond college. And we're on the little boat going down the river. And then on the side of the river is that first grade math teacher, the fifth grade math teacher, the high school math teacher, the community college math teacher, etc. And if those teachers aren't talking to each other, then this person is just floating on a boat, kind of going from one to the next and might not be making the connections that are so necessary for success.
Right. Yes.
Yeah. And that was another, sound like an advertisement for the Intel math program, but that was a nice thing because there were K through 8 school teachers there, and we do work on these open-ended problems, and the middle school teachers would start using algebra, and the lower elementary school teachers would start using manipulatives. They'd be pulling up blocks and other things, and they could both solve the same problem, just from different perspectives. And then they could have conversations about what that meant, that they were taking these different approaches and
Right.
things. Yeah.
That's so
And it was
cool.
good. It's good for a second grade teacher to learn what a seventh grade student is going to be expected to learn and know and understand. And it's important for a seventh grade school teacher to understand what's happening at the second grade.
Right.
And the same thing for me as a college professor. That's why it was so good for me to spend that time thinking deeply about the elementary school curriculum.
Right. Oh, and then another thing that you mentioned, which I thought was really helpful, is you'd mentioned when you're explaining something as a teacher, when the students don't get it, explaining it a different way rather than louder the same way. And that comes back to communication also, you know,
It sure does.
oh my goodness. And because I know that I've fallen into that, right? If I've explained something once and then, you know, someone doesn't understand it, and my first reaction is to explain it the same way. Like maybe I didn't explain it clearly, like the way I was explaining it wasn't clear, when in fact I need to find an entirely different way of explaining it. And gosh, you know, that can be challenging, you know, especially when it's, you know, in the moment. Okay, the way you prepped how to explain something is not working. You know, how do you find that other way to talk about something?
It's a good question. Yeah, it's a challenge. Yep, it's a challenge. And sometimes you might do it and not even realize it, because sometimes, you know, I do remember, you know, when I've had other teachers in my classroom observing me, or when I've been observing other teachers, and then afterwards, you know, you have a conversation, you go out to lunch afterwards and chat about what you saw. And, you know, it's so easy for somebody else to say, you know, you used a move in there that was really good. Like, and for the teacher to be like, I did, it could be just instinctual kind of a thing, you know, you know, to say, you know, you might not have realized, but when you pivoted here and did this, or, you know, it made a difference, you know, or when you crouched down next to the students so that you weren't lording over them, but you were physically crouched next to them and, you know, kind of on an even playing field. Like, I don't know if you noticed that the students' shoulders relaxed, you know, like things like that you wouldn't notice, but that an observer can notice. So I'm a big fan of going in and inviting people to come into your classroom and then go out for coffee afterwards, and vice versa, and to go into other people's classrooms.
Right. Yeah, you learn so much from that.
Yeah.
Definitely.
Yep.
And, you know, and I think you're right too, that it is very easy to not notice things when you're in the moment, whether it's something right or something wrong, right? So having that sort of observation is super helpful, and also reflecting back on it, because it's not, I don't know, I keep thinking about that one example of explaining something the same way, and it's not black and white where there's a professor who's always explaining something differently, you know, the second time, and then there's a professor who's always explaining something the exact same way, not being able to. There's just different levels. I know in some situations you get it right and some you don't, and so it's just, I don't know, it's a skill.
Yeah, well,
I guess learning how
when I was finishing, when I was just starting my teaching career and finishing up grad school, that was when like the calculus reform movement was getting going, and you know, you might be aware, maybe not, but one part of the idea there was to teach calculus not just from an algebraic perspective, but to take a concept, whatever the concept was, and to think about it you know, you can think about it in terms of y equals mx plus b, a line, or you could think of it in terms of some data, you know, a list of data that you could then plot on a graph. And then if you could then connected the dots, it looks linear. So the idea of having like data lead to graphs, to have the equation, and then also to just use words, you know, to describe a relationship. You know, every day there are two more of this thing. Every day there's two more of this thing. Well, what kind of a table would that generate? What kind of, and I'm guessing that now that's just standard, but you know, that when you are teaching an idea like that you do use data and graphs and formulas and words, But that was actually kind of a new idea when I started in calculus. And I even remember going on job interviews, and departments would say like, well, we're teaching with calculus reform books. Like there's this Hughes Hallett book that was like the hot book at the time. You know, are you comfortable teaching with that book, or would you want to teach with that book? And then you go to another institution and they'd say, you know, we are not doing the calculus reform. Like we're teaching out of this other book. Like that's going to be okay. And it was almost there's a political element to the interview questions, as the interviewers were trying to figure out if you were going to be one of those calc reform people or not. Like, and then they wanted a match, you know, they wanted to find a match with whatever the culture was at their particular school.
Right.
You know, and now that it's, you know, over 2 decades later, it's just embedded in the curriculum. Like that's the approach that's just what we do, you know. But it was a big deal at the time. And when I learned calculus, it was very, very formula based, you know, a little bit of graphing, but that's it.
Right. And those transitions are important, right? Going through it, because you don't get to where we are now without having some of the schools embrace it and try something new, you know, and other schools question it, right? I don't know.
Yep. And then it was graphing calculators. Do you allow graphing calculators?
Yes.
And now, I mean, I got a call from my niece this week, you know, saying, Auntie Catherine, you need to show me how to use this graphing calculator because I'm doing my PSATs tomorrow and I don't know how to do it because she uses a TI, you know. So she and I sat on Zoom for you know, half an hour, just kind of showing her, like, find this button, find that button. How would you do this? How would you do that? You know, and then I just briefly, I said, I know you're not going to have to do this on the PSATs tomorrow, but let me just show you, you know, type in the y equals 3x plus 2 and then hit the graph button. And she was like, what? You know, I was like, yeah, that's why graphing calculators are cool. You know? Yeah.
Oh my goodness.
So now it's, you know, standard and to have those.
Right. That's so cool. All right. Well,
yeah, they're new and they're controversial sometimes.
Right. And well, unfortunately, we're at like the half-hour mark right now. And I would love to keep talking about all of this. But I think, you know, before we go, you know, for anyone listening who wants to find out, you know, more about you and your work, your research, your work at the American Mathematical Society, you know, where can they find out more about you?
I think the best thing to do is to go to the website of the American Mathematical Society. And when you're there, you can see, you know, we're a large professional society. Our goal is to advance research in mathematics and to, you know, create connections among mathematicians. And we do that by publishing books, and we publish journals, and we hold conferences and meetings. There's a database called MathSciNet that's in a lot of academic libraries, where you can look up like the math literature. So we maintain that database for researchers, and you know, we run webinars and do other kinds of things. So I think that's a really good place to start. And you can learn a little bit about the work of professional societies to help support mathematicians in what they do. So thank you.
Awesome. Thank you so much. And thank you for this opportunity to interview you today. Honestly, it is such an honor, and I really appreciate it.
Well, it's been a delight to meet you, Allison, and I love that you're making lemons during this crazy pandemic time by starting this podcast and you know, helping to keep us connected, to keep us talking and communicating and connected. So you're doing great. Thank you.
Awesome. Thank you so much.
Take care.
And if you're listening to this today, thank you so much for listening, and I'll see you in the next episode. Bye.